little different. Alright, so in this more complicated example of a simply supported beam, we've got a far more complex set of loads here. We're asked to find, in this case, only one reaction, the vertical reaction at A. Notice the units we got: 4 kilonewtons per meter, 8 kilonewtons per meter, 10 kilonewtons per meter, 2 kil. They're all force per length. They're intensities at different location of the distributed load. We don't have a single concentrated force. We have a spread out series of forces that are varying in their intensity. That makes this kind of, well, complex. So first thing let's do is the free body diagram. And let's lay out our 7-meter long beam, right? And we are going to have then a set of pin reactions at the left. There's AY, there's AX. Find the vertical reaction at A. We only want AY. And then we got BY over here. Even though we're not looking for BY, we still have to have it. If you don't, I'll get mad, and you will not get the same kind of quality of your response. Now I'll put the distributed load in. We've got a trapezoid, and we've got a trapezoid. Right now, a lot of people will usually break up trapezoids into a rectangle and triangle. And I tell you, don't do it. Resist the temptation. But I like rectangles and they're easy. Yeah, but you still have to deal with a triangle, and if you do the rectangle, you gotta do math. Like, if I chop off this thing as a rectangle, don't do it. But if I do it, that's 2, and the height of that is not 10 anymore, it's 8. But there's 8 over here, I don't understand. 8 from here to here. It gets confusing. Don't do it that way. It's all acting downwards. Instead, do it this way. And that is, chop this up into multiple triangles. It is so much easier to work with. Right now, we only care about the left-right aspect of the centroids. So, for instance, this one, towards the big end, 1/3, 2/3. So 1/3, it's 1 meter over from there. This one, also 1/3, 2/3, and that's at 2 meters over. Now go look at this one. This is 4 meters base, so it's going to be at 1/3 from the big end. Remember, we don't care about the height part, we only care about the left-right nature of it. And so from its base, that perpendicular distance over, that's going to be 1/3 of the base, that's 4/3. And plus, we, of course, are going to have to get 3 meters or deal with that whole distance over to B. And this one will also be 4/3. The area is going to be 1/2 base height, so that's going to be 1/2 of base, 3 meters, times height, 2 kilonewtons per meter. Look at the units. Meters cancel out. So 2 goes away also, and we're left with 3 kilonewtons for the effective load right there. And then this one, 1/2 base times height, right? And so 1/2 of the base of 3 meters times the height of 10. I don't have to do any addition or subtraction. That's kind of nice. 3 meters times 10 kilonewtons per meter. Again, units. And, ooh, that's 10 divided by 2. That's 5. That's 15 kilonewtons. Oh, I like this. This is working out kind of nice. This one's 1/2 base times height. It's 8 high. It's 4 long. So that's going to be 1/2 of 4 meters times 8 kilonewtons per meter. This gets tedious right now, all the units. 4 divided by 2 is 2. 2 times 8 is 16. So that's 16 kilonewtons. And this one is half that height, right? That's a 4 sitting out here. So 1/2 of 4 times 4 is going to be 8 kilonewtons acting effectively through that location, right? This just makes things so much easier, because look what we can do now. We're going to do, the second step, that was a free body diagram. Now we can do our equilibrium to find AY. Do it all in one step. That's kind of nice and pretty. we're going to sum moments about point B because it gets rid of that by that we don't want. AX is going to be 0, but it would also pass through. And so let's take, then clockwise is positive. We got 7 meters times AY, then minus the effective force of 8 kilonewtons times its moment arm. Right? That's going to be 7 meters minus the 4/3 meter. And then we got minus the 16 kilonewtons times its moment arm, which is going to be 3 plus the 4/3. Right? And then we got this one here, that was 15 kilonewtons. I usually do all of that math right here, but we've got it already done, so what the heck. Times its moment arm to B of 2 meters, and then minus then this last piece of 3 kilonewtons times its moment arm of 1 meter. Set it all equal to 0. And what are we going to get here? Well, let's do a little bit this in pieces. 7 minus the 4 divided by 3, that number is 5.67 meters right there, and times the 8, that's 45.33. Put that, dump that in memory. This is going to be 3 plus 4 1/3, so that's going to be, of course, 4.333 times the 16. Add that in to memory to go with the other one. And then we got 15 times 2, that's 30. Add that in. 3 times 1, add that in. That total stuff is 147.6667. And so 7 meters times AY will be equal to 147.67 kilonewton meters. Checking out units. Meters grow away. I actually do have units of force. So AY will be equal to 21.1 kilonewtons acting up. All right, let's do a little quality control check on this whole thing. Right? Let's see, the average over here of the 4 and the 8 would be 6. The average of the 10 and 2 would also be 6. So that's like having an average 6 kilonewton meters over the whole length. So that's 6 times 7. Oh, that's 42 total kilonewtons. Hey, is that what we ended up with in reality? 8 plus 16 plus 15 plus 3. Ding, 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 ding. 42. That's kind of interesting. Now, if this was uniformly, we'd get half and half, divide by 2, 21 on either side, and we ended up with 21.1 at the left. We got a little bit more, and that sort of makes sense, because look at how the right-hand side gets sort of more of it shoved over to the center. Sorry, it's all crooked, isn't it? Shoved more over the center. This is shoved more to the center, but it's kind of spread out, not quite as peaky. A flatter slope, in other words. And so, yeah, a little bit more of this load gets dumped over to A than you have to B. That's kind of an interesting result to end up with, right? So it kind of feels good that slightly more than half of the load ends up over here as an effect at AY. Cool. There you go.